Okay, good morning, class. All right, so good morning, Junyuan. Okay, so today we continue for the last subtopic in chapter 6, right? That is to calculate the electricity. Okay, Mhm. okay, so energy efficiency. Okay, so before this, also we already learned how to calculate the efficiency for the transformer, right? So there is output divided by input. Okay, the power of output divided by power of input. Okay, and you have to times with 100. Okay, because usually the efficiency, okay, they're calculated in the percentage. Okay, so the percentage of the energy input, okay, converted to a useful form of energy output. Okay. So the next one is the for most electrical appliance, okay, efficiency is always less than 100%, okay, due to energy loss in the form of heat and sound. So let's say if you supply, okay, let's say using we take example as your refrigerator, okay. So let's say the energy supply to the refrigerator is 200 joule, okay, but we cannot get 200 joule, okay, to use, okay, to cool down the refrigerator. So there must be energy loss, okay. So due to the heat, so if you feel at the back of your refrigerator, you can feel hot, right? So mean there will be energy loss, okay, to the energy loss, okay, and it transform to the heat, and also and can hear sometimes the refrigerator also have sound, right? So they're transferred to the heat energy and also the sound energy. So that's why you cannot get 100%. So even you give like 200 joule, okay, to your refrigerator, you will not get 200 joule of energy output, okay, to cool down the refrigerator. So it must be less than that, okay. So of course cannot be 100%. Okay, so this is the formula for to calculate the energy efficiency. Okay, so just now, if for the transformer there is a power, right? So output power divided by input power times 100. So that one is for transformer. Okay, we calculate in the form of power for it efficiency. Okay, for the energy efficiency for electrical appliance, usually we use energy. Okay, so means the energy, what's the unit for energy? The unit of energy must be in joule. Okay, must be in joule. So energy efficiency is actually equals to useful energy output, okay, divide by energy input supply times 100. So example like I just told you just now for refrigerator. So they say we supply 200 joule refrigerator to the 200 joule of energy to the refrigerator. So what that we get is actually, let's say we got 180 joule only. So the 20 joule will be transformed to heat energy and also sound energy. So the useful energy here is actually only 180. Okay, then you divide by the energy that being supplied to the refrigerator, that is 200 joule. Okay, and then you just times with 100. Okay, so you will get like, for a moment, this one is 2, so you will get like 90%. Okay, so this is the efficiency, so only 90%. Okay, so this is the example. So let's say the photograph below shows a lighted filament bulb, okay, a 60 joule of input, okay, so 60 joule of input electrical energy supplied to a filament bulb, okay, and 3 joule of useful energy output in the form of light. So what is the energy efficiency of the bulb? Okay, so this one they put 60 joule, they give the 60 joule energy, okay, to the bulb, okay, but only 3 joule of useful energy are put in the form of light. So this one should be 3, this is the formula, okay, so 3 you divide by 60 joule, okay, times 100, okay, so you will get 5% only. Okay, so only 5% is the energy efficiency for the bulb. Okay, so means like 57 joule. Okay, 57 joule is released, okay, as heat. Okay, so there's a lot of loss of energy here. Okay, so even we supply 60, we only got 3 joule. So this one is a very low energy efficiency, only 5%. Okay, so 50 joule of energy output waste into the form of heat that released to the surroundings. So if you hold the bulb, okay, after you light up the bulb, okay, for some time, okay, and then you switch off, then you hold the bulb, you can see the bulb is hot. So means there is a heat energy that being released, okay, while you using the bulb. Okay, so you only got 3 joule to light up the bulb, and another 57 is already transferred to heat energy. Okay, so the technology which applies the concept, okay, if energy efficiency. So lightning device. So this is the filament lamp, okay, and this is the compact fluorescent lamp. So this is the energy saving lamp, and this is LED. Okay, so let's compare the efficiency for these three. Okay, so energy efficiency, okay, the maximum electrical energy converted to light energy is almost 10%. So let's say if you give 90 joule, only 10%, okay, that is the maximum, okay, only 10% of the 90 joule, okay, that we use to light up the bulb, okay, that we use to that we release as the light energy. So another 90% is lost to the surrounding, okay, as a heat energy. Okay, for the energy saving lamp, so the maximum electrical energy converted to light energy is 50%. Okay, almost 50%. So let's say if I apply same amount of electric energy, like say just now 90 joule. So I only got almost like 45 joule. Okay, to use as the light energy that will be released as the light energy. So another 50%, like 45 joule, it will release as the heat. Okay, and this is the LED. Okay, so LED, the maximum the energy converted to the light energy is almost 90%. So this is the highest. Okay, so let's say just now if I supplied 90 joule. Okay, if I supply 90 joule to the 90 joule of electricity to the LED lamp, so I will got almost like 81 joule. So only 9 joule that will be released as heat to the surrounding. So you can see here the LED lamp is very good as to use as the light bulb, okay, in our house, because the energy efficiency is very high, so it will save costs. Okay, it will save costs. Okay, so I'm sure if you buy the electrical appliance, so let's say refrigerator, you buy a television, okay, so you will see this kind of symbol, okay, they will paste like a sticker there, okay, and this is actually to say what is the energy consumption here, okay, what is the energy efficiency here, okay. So let's see the first one, this is the energy rating, 1 to 5 star, okay. So this one, it says more star means more energy saving. Okay, and this is the appliance type. So what type of the electrical appliance that you buy? Okay, and this is the information on the brand. Okay, and model. Okay, on your right side. Okay, and this is the appliance energy rating. So equal the number in energy rating. Okay, so means this one is 5 star, right? So they will put 5 here. Okay. And this is the energy consumption, okay, 112 kilowatt, okay, per year, okay. And this is the energy saving compared to 2 star rated product, okay, so in percentage. So you can see here it says this product, like this product is let's see, 51.55% less energy than an average product. Okay, so me it like save like 50% of energy if you compare to to compare to another product. Okay, and this is the testing standard use. Okay, so that is the information that you can get, okay, if you buy the electrical appliance. So you should see the sticker there, what is the energy rating, okay. Usually 4 to 5 star is better one, but it's quite expensive lah. Okay, like aircon also, air conditioner also, they got the star rating like that. Okay, so usually if you want to save electricity, you buy the inverter one. Okay, so use of electricity in electrical appliance. So electrical energy is the energy supplied by the source to all electrical components which connected in a circuit when the current flows through the circuit. Okay, so what does it mean by electrical energy? So the energy that be supplied, okay, by the supply to the electrical appliance, okay, that they must be connected. Okay, they must be connected in a circuit so the current can flows. Okay, so that's you call it as a electrical energy. Okay, this one I think you already know. This is the electric meter. Okay, what is the function? Is to measure the quantity of electricity used. Okay, so the reading of the electric meter is taken at the end of every month for the purpose of determining the cost of electricity consumed. Okay, so this one usually they will use the unit in kilowatt per joule. Sorry, kilowatt per hour. Okay, so this one usually the unit in kilowatt per hour. So how much for 1 hour, what is the energy that you use, what is the electrical energy that you use, but this one they use it in kilowatt. Okay, so electrical power is the rate of energy, okay, rate of electrical energy used by an electrical device. Okay, so the electrical power is defined the amount of energy transferred in 1 second. So in 1 second, how much does the energy being transferred? Okay, so the SI unit is watt or joule per second. So this is the formula. Okay, P is equals to E over T. Okay, so P is actually the power, okay, electrical power in watt. E is actually the electrical energy, so in joule. Time must be in second. Okay, so this is the formula for electrical power. P is equals to ET. Okay, what is the electric current? So electric current is the rate of flow of electric charge. Okay, rate of flow of electric charge, okay, through a conductor. So this is the meaning of electric current. A rate of flow of electric charge, or sometimes they say rate of flow of electron, because electron is actually the current is actually is the electron that flows throughout the circuit. Okay, so this is called sometimes rate of flow of electron. So the SI unit for current is ampere and the electric charge is coulomb. Okay, so the unit is C, okay, for the electric charge. Okay, so the energy electric supplies to the electrical components when 1 coulomb charge flow across a potential difference of 1 volt is equals to 1 joule. Okay, so let's say 1 coulomb, okay, 1 coulomb of charge, okay, that flows across a potential difference of 1 volt, okay, is equals to 1 joule. Okay, so this is the formula. I is equals to Q over T. Okay, I is actually in ampere. Okay, Q is actually in coulomb. Time is in second. So later we will try to use one by one. Okay, for this formula question. Okay, for this formula. Okay, so what is the meaning of the voltage? So the voltage is defined the electrical energy, right, to use to move or unit a charge through a conductor. So let's say I already told you just now the current is the rate of flow of electron, right, means a charge. So the energy, right, the energy to move the electron, okay, from one point to another point, okay, we call it as a voltage, okay, and that one is the electrical energy. So how much the voltage is actually how much the energy that you use to move the electron from one point to another point. Okay, so that is the voltage. Okay, how much energy that you need, okay, to move, okay, one electron from one point to another point. So how much energy that you need, that is called as a voltage. Okay, so the SI unit for the voltage is volt. Okay, I'm sure you already know this one when you learn electricity on form 2, right? The parallel and the series, right? Series circuit. Okay, so this is the formula for voltage. V is equals to E over Q. Okay, so there's a lot of formula in this part. Okay, V is equals to E over Q. So E is the joule, okay, the energy, okay, in joule, and electrical charge Q is in coulomb. Okay. Alright, so let's try this one. It said the total electric current that flows through an electrical appliance can be determined relating power, voltage, and electric current. Okay, so the electrical energy can be used using the formula below. So this one actually, before this, I already teach you for this formula when you want to calculate the fuse, right? What type of fuse that you need, whether 1 ampere, 2 ampere, 3 ampere, right? So I use this formula to calculate what is the current flows. Okay, then I choose the higher one, okay, compared to the currents that flows. Okay, so this one actually we already learned how to use it. Okay, so this is the example. Okay, so this is the iron, right? And they give you the voltage here and the watt here. So P is equals to VI, right? So the power here is already given 1700. Okay, the voltage here is 240. So can you calculate from me the current here? What is the value of current here? Can you calculate for teacher what is the current here flows? What is the current flows here? 7.08. Okay, very good. So I is 7.08 ampere. Okay, so you take only like 2 decimal point is enough already. Okay, so this is how to calculate. So let's check whether the answer is correct or not. Okay, so using this formula, yes, 7.08 ampere. Okay, so now we want to calculate the electrical energy used in costing unit is uses in costing is measured in kilowatt per hour. So this one is kilowatt hour. So this one already told you just now, right? So the our electric meter using kilowatt hour. Okay. So hence the amount of electrical energy in kilowatt or unit power of appliance must be stated in kilowatt and times must be in hour. But this one is only for calculation of the cost of electricity. Let's say for your electricity bill, so for the power must be in kilowatt, okay, and for the time must be in hour. So let's say they give you in minute, you have to change in hour. So they say if they give you in watt, you have to change to kilowatt. Then you can calculate what is your bill, electricity bill for that month. Okay. But let's say other questions. So for other question, not like to try to calculate the electricity bill. So that one you just use watt and second. Okay, watt and second. Okay, but only for the electricity bill, you want to calculate how much. Okay, so that one we use the kilowatt and hour. If not, only watt and second. So the electrical energy used for electrical appliance can be calculated as below. Okay, so this is the formula. Okay, so before we multiply the power and the time, you have to change the unit first. Okay, this to change to kilowatt, time change to hour. Okay, so the total of unit energy used time cost per unit. Okay, so this is the example. So let's say Stella takes 50 minutes, right, to iron a piece of clothes with a 2 kilowatt iron. So calculate the cost of electrical energy used to iron the clothes if the rate is 24 cent. Okay, 24 cents. So how to calculate for this one? So we use E is equals to PT, right? So here is the power, right? And it's already changed to kilowatt, so it's okay. We just use that one. Okay, so 2. Okay, and the time just now I said must be in hour, right? So 50 minutes you have to change to hours, so means you have to divide by 60. Okay, so try to calculate for me. 2 times 50 over 60. What is the answer? So what's your answer for the energy here? Yeah, 0.5 joule, right? So the energy here is 0.5 joule. And it says the rate that used here is only 25 cent. So you just multiply with the 0.24. Don't multiply with 24, right? This one is actually in cent. So 0.5 times 0.24. So how much you have to pay? I think like 0.12. So let's check whether it's correct or not. Yeah, so 12 cent. So 0.12 means 12 cents. So you only need to pay 12 cents. Okay. Right. So later I will give you one question. Okay. About the electrical energy. So uh, you have to calculate the cost. Right. So this one is ways to increase the efficiency of the electrical energy use. Okay. So increased energy efficiency means you have higher level of useful outputs. Okay. So let's say just now for we compare the bulb, right? So you can see the LED is 90%. Okay, so this one should be the higher level on the useful of output. So means you have to increase the output of energy so you can increase the efficiency, right? And less input power, okay? And ways to increase of the efficiency of electrical energy use, you use more energy efficient things, and use of electrical and appliance wisely, and prevent excessive energy usage, and use air conditioning efficiently. Okay, so means if the weather is not too hot, okay, maybe you can you do maybe we just use the temperature that it's not so low, so this one can save the cost of save the cost for the electricity bill. Okay, so ways to save the electrical energy consumption. So replace filament lamps with LED lamps. So LED. So usually, mostly now we use the LED lamps. Okay, and ensure all doors and windows are closed when the air conditioner is used. Alright, and the refrigerator door must be closed tightly. Okay, so there will be not the air, the cold air inside of the refrigerator will not release to the surrounding. Okay, and research and development to produce appliances which are more efficient, and clean and remove dust regularly from air filter of the air conditioner. Okay, and use free wind and sunlight instead of dryer. Okay, so we just they say some of our house have a dryer, right? Washing machine. Okay, so you can just use sunlight, okay, to dry your clothes. Okay, cooking several things at the same time in the oven, and use washing machine when it's fully loaded, and clean the filter and fin of the air conditioner and refrigerator periodically. Okay, so if there's still dust, means your refrigerator have to work hard. Okay, work harder to produce the cool air. So we clean it regularly. Okay, so that's for the electricity, calculating the electrical energy. Okay, now I will give you one question. Okay, and you have to try to answer. Okay, so let's see for this one. Okay, for this one, they ask you to determine the energy used by the toaster. Okay, let me keep bigger. Right. So try to calculate for this one. So this one you use E is equals to PT. You see that one 60 watt is not 60 watt is not in kilowatt, so you have to change first, and that one is minute, you have to change to hour. So E is equals to PT. B. Entang got B. Any other people got another answer? So power, I already told you have to change to kilowatt, right? So 60 divided by 1000. Okay, and the time here, okay, have to change into hour. Okay, so 30 divided by 60. Okay, so 60 divided by 1000 times 30 divided by 60. So you will get 0.03 kilowatt per hour. Very good. Ito. Kilowatt hour, sorry. Okay, so this is the energy that we use. Okay, so let's try another one. Okay, for this one, you have to calculate the bill, the electricity bill for this question. Wait. Mm, right, I think it's on this. Alright. Wait, hold on. I find the question. Okay, this one. Okay, so this one is diagram shows the electricity bill. Okay, from TNB web. Okay, so it says here from 18 February to 19 March. Okay, and they give you like if 200 first 200 blocks. Okay, you will charge 0.218 cent. Okay, but if after that another 100 you will charge 0.334. Okay, and another 300 after that is 0.516. Okay, so this one the table shows the electrical appliances used in the teller's house for 1 day. Okay, so this is only 1 day, and this one is 30 days, so that's after that you have to times by 30. Okay, so what is the total cost for the electrical appliance in table from 18 February 2018 until 19 March 2018? Okay, so can you try to calculate for me what is the bill uh for for the tailor? Okay, for the tailor. So you have to find one by one first. How much does energy that is used? Okay, but this one you are lucky because you already changed the kilowatt, and this one also already in hour, so it's okay. just multiply one by one, right? And then you have to sum off all the energy used, then times by 30. Okay, so try to calculate first. Okay, can you calculate? Okay, so let's try to see. Okay, for this one is actually, oh, I cannot wait. One moment. Okay. Okay, let's make sure. Okay, so let's try to calculate first, right? How much does the energy that the tailor use? Okay, so for this one, I already teach you we use E is equals to PT, right? So the power here for the machine is 0.1 times 5. So you will get 0.5. Okay, 0.5. So this one is 0.5. Okay, for this one, okay, use the same formula PT. Okay, so the power here is 0.125. Okay, so how many hours you use? 6 hours. Okay, so remember this one in kilowatt. Okay, the P must be in kilowatt, the time must be in hour. So 0.125 times 6. Okay, 0.125 times 6, you will get 0.75. Okay, so this one 0.75. Okay, and then for the electric fan, okay, for the electric fan also I use the same formula. Power is 0.05. Okay, then we have to times with 12 hours. Okay, so 0.05 times with 12, you will get 0.6. Okay, but remember they have 3 electric fans. So after that, you have to multiply with 3. Okay, so 0.6 is only for one electric fan. So if 3, so multiply by 3, you will get 1.8. Okay, so this one 1.8 for the electric fan. Okay, and then for iron is 1.5 kilowatt. So 1.5, same formula, still PT. Okay, 1.5 times how many hours used? 3 hours. So you got 4.5. So this one is only for 1 day. Okay, so then we just add all that, 0.5 plus 0.75 plus 1.8 plus 4.5. Okay, so you will get 7.55. Okay, 7.55 is actually for 1 day. So this one is actually 30 days. So 7.55 you have to multiply with 30. Okay, so you multiply with 30. So you will get 226 0.5 kilowatt hour. So this is the energy that being used in 1 month. Okay, 226,226.5 kilowatt hour. Okay, but the question want you to find how much the electricity bill for that month. Okay, so you can see here 226.5. So 200, the first 200, okay, we calculate it 0.218 per kilowatt hour. Okay, so 200, because this one is already more than 200, right? So 200 on 0.218. Okay, 43 ringgit 60, 43 ringgit 60 cent. Okay, and then you have still more balance like 26.5, right? So 200 we already calculate, so the balance is to 26.5. So 26.5 we have to use the second one. Okay, another 100. Okay, so this one you have to multiply with 0.334. So 26.5 times 0.334. So you will get 8.85. Okay. So remember 200 we already calculate. So balance we still got 26.5, right? So 26.5 you use another, the second one. Okay, because this one is 200 first. First 200, 0.218. Another 100, so 0.334. So to 26.5 you have to times with 0.334. So you will get 885. Okay. So after that you add 43.6 plus 8.85. Okay. So plus 43.6. So you will get 52.45. So let's check the answer. Yeah, so the answer is C. Okay, 52 ringgit 45 cents. Okay, so that is the electricity bill for the teller for that month. Okay, so 52 ringgit. Okay, so 43.60 cents, 8.85, so you got 52.45. So this is amount that it has to pay. Okay, so this is how you calculate the electricity bill. Okay, the example, okay, for the calculation. Remember, must be in kilowatt per hour, kilowatt hour. Okay, so I think I will stop until now. Okay, and I already assign you a quiz for you to answer in tutorial. Okay, so because we finish at 9, right? So I will start first until 9. So see you next week on Tuesday. Okay, and please tomorrow for Tuesday we will discuss. Okay, the tutorial I give. Okay, and I will give another one for this 6.4. Okay, and I will assign in GC. So please answer first, then later on Tuesday I will ask one by one. Okay, for the answer. So please be prepared. Okay, so we won't waste so much time for waiting. Okay, so thank you class. Okay, so see you on Tuesday. Okay, and take care. Have a good weekend. Okay, welcome.